Why this is such an important thing? Since Albert Einstein published the theory of special relativity in 1905, one equation, which is this, has been a headache for people hoping to discover the stars. Yet also something of an escape for those who dream of traveling through the time. This formula completely transformed our understanding of gravity, space, and the time. Perhaps it's even changed our perspective on time as a kind of position in a fundamentally different way. When we think about it in more detail, it not only deepens our understanding of time, but also implies that the traveling at the speed of light or beyond it is impossible. Considering how vast the universe is, the speed limit severely restricts our ability to move around the cosmos. Yes, speed is limited, but is the whole story really just about the limit of speed? In Einstein's equation, E represents energy, M represents mass, and C is the constant speed of light in a vacuum. Approximately like this, because the C square is such a large number, even very small amounts of mass require enormous energy to accelerate their speeds approaching that of light. This relationship explains why the only particles capable of traveling at light speeds are those with no mass at all, like photons. But all the things that I said is like a short answer. It's like a shortcut for why objects with mass can't reach or go faster than the speed of the light. But the full use Einstein's equation, physicists usually add one more variable. The equation alone doesn't completely explain why light speed can't be passed. So that's where the Lorentz factor is gamma comes into the game. Gamma is formulated like this, and the gamma shows how an object's speeds change the way it experiences time, length, and the other physical properties. When an object moves very slowly, just as a small fraction of the speed of the light, this factor is basically like 1. But how? Let me explain. This fraction is going to converge like 0. So 1 minus 0 is like equal to 1, and square root of the 1 is 1. Easy. Gamma going to be like 101. So it's going to equal like just 1. So easy, right? So as a sum up, when an object moves very slowly, just a small fraction like we calculate here, this factor, which is gamma, is basically 1. So it doesn't change the equation that much. What happens when the speed gets closer and closer to light speeds? It's also easy. Let me show you. Gamma can be like something like this. Going to be like 1. 1 minus 1 is going to be like 0. So this is mathematically undefined. So when this E stands for the total energy of the relativistic object, it's going to be like gamma mc². So it's physically impossible to make a mass reach the speed of the light. But it's not just about energy. It also shows how space and time get warped. So a moving object experiences time slower, which we call time dilation. And it gets shorter in the direction of the movement, which also we call length contraction. Its mass effectively increases. And this is also called relativistic momentum. So as a sum up, as we get closer and closer to the light speed, all these effects get stronger, and eventually the physics as we know it breaks down. When an object moves fast enough that the denominator hits 0, we can't divide by 0, which makes the equation stop working, and the variables inside it is impossible. This part is so important. That's why the speed limit can't be broken. But what does this breakdown actually mean? To understand that, we need to look at the physical systems is modeling, space, and time. After Einstein published special relativity, his mentor Hermann Minkowski, who remembered Einstein as constantly skipping lessons, a real lazy one, not interested in the mathematics at all, and that he had received a very weak mathematical education, realized that if Einstein was right, then space and the time aren't two separate things. They are connected as one system, and everything in the universe moves together in space and time. Moving through one of these vectors limits how fast we can move through the other. To imagine this, think about moving north at a constant speed. We can turn and move east at the same time. Where is this? Going to northeast would mean we are moving slower in both directions. The same trade-offs happen when we move through space-time. Since our normal movement in space is much slower than the speed of light, we mostly feel like we are moving through the time at relatively steady speed. But if an object could move through space at the speed of light, it wouldn't move through time anymore. So this is kind of time dilation modeled by Lorentz factor, showing how time slows down for objects moving at extremely high speed. This is just one of my many details hidden in mc². For example, the c in Einstein equation refers to the speed of light in vacuum as calculated for outer space. Einstein's C constant only applies in vacuum. For example, light slows down by about 25% when it goes through the water. And scientists can make low mass particles like charged electrons move faster than these photons in the water. This means some particles can move faster than light underwater, creating something like a ghostly blue glow known as Cherenkov radiation. Even with these exceptions, the most important takeaway from mc² still holds. As far as we know, nothing can travel faster than the light in a vacuum. But that doesn't stop scientists from imagining what might happen if we could. For example, let me think like that. If you are in a spaceship moving near light speed, your view will probably look kaleidoscopic. It's like a Coldplay song. Things in the direction you are moving will look blue shifted. Maybe since that you are going to sing like I'm blue da bi di ba 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 da da da. Let me get back to business. While object to your side and behind will look like red shifted. And if somehow you could reach or even pass the speed of the light, it could act like a kind of time travel, maybe letting you chat with Einstein himself and rewrite our basic understanding of physics. So that's the end of the story. Do not forget to like and subscribe. Support me on the Patreon. Thank you and goodbye.